The next problem we solve with FORM is one that we have looked at before, which was called example A2 earlier this week, but we are now going to solve it with FORM and go through the steps. How it's different from just the previous example is, instead of normal distribution for y and q, we have log normal distribution for both of them, and we'll see what difference it makes to the results. So let's just take a few seconds to read the problem, and then we'll start the solution. So it makes sense, as we had discussed when we solved this problem before, is we take log of y and log of q and express them as x1 and x2. So our limit state function in the space of basic variables is x1 minus x2 plus log of a. So it's a very simple linear function, and we should go for a linear map. So u is x minus mu over sigma. Actually, this is a normal to normal transformation, just like it was in the previous example B1. So we are not losing any information probabilistically. So with this, we get a similar limit state as we did in the previous problem. It's a linear function involving u1 and u2. And as you see, I have put the numerical values. You need to go through the steps to get the equivalent mean and standard deviation for the corresponding normals, starting from the log normal. So I've already done those, and what you see on the screen is the final result of the limit state equation in U space in terms of all the given constants. The one unknown constant is log of a, and so part of the exercise is to find out what the value of a is if the reliability index has to be 3. So it's the same problem as before. We have to find the distance of a straight line from the origin, and we have we did the same thing in the previous problem. Here it's given in terms of log of a, and if beta has to equal 3, then that gives me a solution of a about 45 square inch, which is the only feasible solution. But interestingly, our previous answer when both were normal random variables was 50 square inch. So now we have 45 square inch, and this is just a reminder that the answer to any reliability analysis not only depends on the mechanics, but depends on the underlying assumptions in the probabilistic aspect of the problem, as well as the method taken to solve the problem. So this is the minimum distance, and now we can find the coordinates of the minimum distance point, and that is respectively minus 2.5 and plus 1.7. So the similar thing as we saw before is that the most likely point for the strength variable is lower than the mean. It's near the left tail. It's 2.5 standard deviations below the mean, and for the load it's almost 2 standard deviations above the mean. So it's 1.7 standard deviations above the mean, and in comparison the numbers were a little different. Previously I think it was something like 2.7 for the strength and about just 1 for the load. So again, these results depend on the distribution and the map. So the design point is 3.26, 7.07 in x space, and if we now exponentiate them to get back y and q, the values are 26 ksi and 1170 kip. So these numbers are different from the previous example, and as I am saying, it's because of the distributions of y and q are different.